So we want to think about complementary angles as, they're adding to 90 degrees. So when we say sine and cosine, we actually mean the or cotangent and of cotangent and tangent. Cosine means complement of sine. It's got something to do with the 90 degrees, which is very important. So if we say use two angles of 40 degrees and 50 degrees, they're complementary. We're going to come back to this. So if we look at this triangle here, if I look at sine theta, it's B over C. So we can write that. If I look at cos theta, I see that it's A over C, right? Adjacent over hypotenuse. Now, if I then look at the other angle, notice in a right angle triangle, we've got one right angle, that's 90. So the other two angles have to add to 180, or the three angles have to add to 180, so the other two must be 90. Hence why if one is theta, the other is 90 minus theta. So if we say, well, sine of the other one, 90 minus theta, that's equal to opposite A over C, right? And then if we have cos of 90 minus theta, then that would be the adjacent now, which is B, over the hypotenuse, which is C. Notice that we have a crossover, that sine theta is equal to cos 90 minus theta, and cos theta is equal to sine of 90 minus theta. They're equal to each other. So what's this mean? If two angles add to 90, for example, like sine 40 and cos 50, the sine of one is equal to the cosine of the other, right? And we can use any number of examples with that. The same with 35 and 55. So if I said, well, cos of 35, right, that would be equal to sine of 55, because 35 plus 55 is equal to 90. So now this gives us these relationships that are listed here. Sine theta equals cos 90 minus theta, etc. This works for tan and cot because they're complements of each other, and sec and cosec. So the co is complement of. And so we see these relationships in action. And I always like to remember sort of one angle. So 40 and 50 is a nice pair to remember. That 40 of 1, or sine of 40, is equal to cos of 50. A tan of 40 is equal to cot of 50, etc. So now we're going to have a look at some examples and see what happens. So let's have a look at these two first and see how we can manipulate it. So number one, we'll call sec theta minus cosec 90 minus theta. Now basically, as we sort of think this through, sec and cosec are complements of each other, which means that sec of theta is actually equal to cosec of 90 minus theta. They're complements. That's its definition. So therefore, I can just rewrite this and say, well, I could rewrite the fact that these relationships hold true from above. So cosec of 90 minus theta is equal to sec theta. So if I then think about this whole relationship, it's going to be sec theta minus sec theta, which of course is the same thing, 0. So there we have it, it's equal to 0. Now, these are two angles I used earlier, 55 and 35, if we have a look at number 2. As we think about the second one, well, sine of 55 and cos of 35, well, 55 and 35 add to 90, which means that, what? Well, sine 55 is equal to cos of 90 minus 55, or the other way around. Cos of 35 is equal to sine of 90 minus 35, because 55 plus 35 is equal to 90. And so as we go along, we can say, all right, let's rewrite one or the other in terms of the other one. So it becomes sine 55 over sine of 90 minus 35. That's what cos 35 will become. And we see fairly clearly that it's sine 55 over sine 55. And if we do that, that's equal to just 1, which is what we get. So we've got this relationship with tan, or equation. We want to solve for k with tan and cot. So if it's equal, because tan and cot are complements of each other, then if this relationship holds, then the two angles have to be complementary. They must add to 90. That's the only way this could be true. For example, tan 40 is equal to cot of 50, or tan 50 is equal to cot of 40. So we use this fact and say, okay, well, those two angles added together, 15 minus k and 2k plus 60, is equal to 90. So we're going to go ahead and add those together. Plus 2k plus 60, and that's equal to 90. And if we find that, we're going to solve those. 15 plus 60 is going to give me 75. And we get minus k plus 2k is k, and that's equal to 90, so we get k is 15 degrees. And that's it. We're going to be able to have that and solve it easily if we understand the way that complements work, that they're simply adding to 90, right? And we see how we go.